Hello everyone, welcome to our audio slide presentation. I am Igor Cadota from the Technological Institute of Aeronautics, and for the next minutes I will be discussing our recent paper on wireless networks, published in Computer Communications. The goal of this work is to develop a mechanism to estimate the numbers of active queues in a network operating with the 802.11e standard. In this slide, we can see a wireless LAN composed of an access point and 3 QoS stations. Looking inside any of the stations, we can see that each contains a set of transmission queues, each belonging to a different access category. There are 4 access categories: voice, video, best effort, and background. They differ by their transmission parameters, what allows the stations to provide differentiated quality of services among categories. In this work, we are interested in estimating the numbers of active queues, in other words, queues that are attempting to transmit packets. In this particular scenario, we have a total of 5 active queues, 2 of access category 0 or voice, and 1 of each of the other access categories. Well, given a network scenario, we estimate the numbers of active queues using the mechanism in this slide. First, we identify MAC events and process them into the events probabilities. Those probabilities are inputs to an extended Kalman filter, which in turn gives us the estimates. This mechanism is the main contribution of our work. It is simple and standard compliant, therefore suited for networks that aim to provide a differentiated quality of service for different traffic categories. Other advantages of this novel mechanism are: it does not need management nor control packet exchanges, thus not adding overhead. Also, it runs only in the access points, therefore not adding complexity to the mobile stations. In order to assess the proposed mechanism in an insightful scenario, we simulate an application of the estimates by adding to the mechanism an optimizer from the literature. In essence, it uses the estimates from the AKF to calculate the optimal contention window sizes to be used by all active queues in the network. Those sizes are periodically broadcast by the access points within beacon frames. Aiming at assessing the filter tracking speed and accuracy in a network with saturated traffic and diverse degrees of fluctuations, we simulate the scenario presented here. Details on each of the access categories will be presented next. Notice that straight lines represent the actual numbers of active queues and the dots estimates. First, we observe the behavior of access category 0 or voice. Now, access category 1 or video. Here, access category 2 or best effort. And finally, access category 3 or background. As we can see, the estimates are accurate and rapidly track network transitions. In the article, we discuss the estimate error causes and evaluate its impact in the network throughput, delay, and jitter delay. Also present in the article is the analysis of the filter under non-saturated traffic, including VoIP sources, and a section for discussing the implementation cost of the mechanism in terms of floating point operations and running time. The main conclusion of the article is that the proposed mechanism is standard compliant and does not add complexity to mobile stations or overhead to the communication, therefore being suited for a variety of applications, including industrial wireless sensor networks and wireless LAN admission control. Thank you for your interest, and we invite you to enjoy the article.